In this example, we're going to take a look at evaluating a limit whenever x and y both approach 0. And in this case, because we have a situation of two variables, the limits are going to be a little bit harder to compute, because what happens here is that whether you approach in 0, 0 from, let's say, the x-axis or the y-axis or some other path, you should always get the same answer. And in this case, that's just not going to happen. Things are much more complicated whenever you have two variables as opposed to one variable. We did not have the situation for one variable. So let's take a look at what happens along each path. So if I first take x equals 0, which is the y-axis, so I am plugging x equals 0 over here. So what limit do I get? So if I plug x equals 0, I get 8, 0 squared, and then x is 0. Now do not plug anything for y, and also let y approach 0. So you are setting x equals something. So in other words, you are approaching 0, 0, but you are approaching 0, 0 from over here along this path right here. So while you are still staying on the vertical axis. So let's compute this limit. Well, on the top we get 0, and on the bottom we get some other value that is not going to be zeros, because remember, when you look at limits, you let the variable get as close as you want to 0, but never actually get into 0. So don't worry about y being 0. It's not. But 0 divided by any number that is not 0 is just going to be 0. So that answer will be 0. Now let's take a look at approaching 0, 0 from the x-axis. So now what if I go from here? What will happen? So now I am plugging in y equals 0 and letting x approach 0. So y equals 0, so I get 8x squared divided by x squared plus a 0 squared, because remember, we're plugging 0 for y. Okay, so now whenever you have these sorts of limits, the first thing to do is just to see if you can plug it in. If you can plug in and you do not get something like 0 divided by 0, then you're fine. But here, if you plug in 0 divided by 0, you do get 0 over 0, which is indeterminate form, which means that some sort of algebraic technique is needed. And in this case, very simple to see that x squared and x squared is just going to cancel. So this is just going to be 8. So I already know that the limit is not going to exist. So as I am doing this, even though they require me to also do y equals 7x, I just know that these two answers are not the same, so that I already know that the limit's not going to exist. But let's I guess finish the problem. So it says, what about along the path y equals 7x? So if you were to approach it from, let's use some other color. So like if you approach it from here, like from y equals 7x, something like that. So you're approaching it along that line. What happens then? So now let's plug in 7x whenever we see y. So x stays unchanged and we are letting x approach 0. So here we get plus. Now 7x is plugged in for y, which will be squared. So that's not going to be just 7, it'll be 49 actually. So you get 8x squared divided by x squared plus 49x squared. So again, if you just try to plain substitution, that's not going to work, because you get 0 divided by 0. However, if you were to just, you can pull out x squared from each term. So here will be 1 plus 49. So then you can see that x squared and x squared will cancel. So the answer is going to be 8 divided by whatever that is 50, looks like. You could probably reduce that, right? So that should be 4 over 25. It doesn't ask me to reduce, so I think either one it'll accept.